Okay, let's start with problem 3221T. Give me a second here, I'll open it up. 3221T. Okay, coefficient of variation. So, the coefficient of variation is just a measure of the effectiveness of the data compared to other data sets. So you have two different data sets here, diastolic and systolic, and the coefficient of variation is the standard deviation divided by the mean. So since they're samples, it'll be S divided by X bar, and then it's turned into a percent. So I open this up in StatCrunch, and I'll have two columns, and they're labeled systolic and diastolic. Now I can do them one at a time to find S and X bar when I do the summary stats, or I can do them same time. But instead of using columns, I would have to use the grouped. I'm sorry, not, yeah, columns. My bad. I was thinking of something else. I do columns. But to do two columns at a time, I use the control button, down arrow. Thought I would. And there you go. See, on the right, I have systolic and diastolic, and it'll have mean and standard deviation on the right. That's all I need, so I compute. So now I got two at the same time. So I don't need that. Oop. Yes, I do. I closed it inadvertently. So let me reopen it. You can see how it's done again. So I go to Stat, Summary Stats column, and I hold down the Enter key as I move down the mouse. So now they're both highlighted. All right, so compute. All right. So I'm going to open my calculator also. So to calculate, they want the systolic. So that's the one that's in the top row. Turn this on, clear the data. So I'm going to take the standard deviation for the systolic, which is right there, highlighted in blue. So that I'm going to use all the decimal places because I'll round off for the percent. So 17.919883 divided by the mean, highlighted 127.2 or 0.7, 127.7. So it's 14.0 to one decimal place. So that's my answer here, 14.0. Oop, not a Q, 14.0. Check answer. Okay, now they're going to ask us to do the same thing for the diastolic. So I just open up my printout again. Now this time I take, and I mind my calculator, this time I take the standard deviation for the diastolic, which is down here, 12.07 3847. Oop. $12.073847 divided by, oops, divided by, and now I'm going to use the mean for this, which is 74. And enter. So this is 16.3%. 16.3. Now, as a direct comparison, the smaller one's the better one. Less deviation or less variation. So I would say that systolic's better. But if they're within 5% of each other, then that's the last question. The coefficients of variation for each data set are within 5 percentage points of each other. Therefore, the systolic measurements vary about the same as the diastolic. Since they're within 5%, that's my best choice. Okay, so that is question 3.221T. I'm going to go ahead and stop the recording and publish.